And now I would like to introduce our speakers. So first of all, we have Attila Szantner. He's the CEO and the co-founder of the Swiss startup Massively Multiplayer Online Science. And he has set up several citizen science collaborations with major game developers. These research minigames engaged already over 3 million players and contributed with over 600 million scientific puzzles solved. These were praised already worldwide by media coverage from the New Yorker and in the front page of Nature Biotechnology. He is also the recipient of the award of the University of Geneva and the IGDA Community Leadership Award. He is an adjunct professor at McGill University School of Computer Science. I would suggest that now Attila presents, and afterwards I will present our second speaker. So Attila, with that, I will pass on the microphone to you.
Thank you. Do you hear me well?
We hear you well.
Okay, perfect. Thanks a lot for having me here. It's I'm working in citizen science for roughly 7 years now. And my experience is that people who are dedicating their time and energy on citizen science is a rather small but very enthusiastic and spirited group. So it's really great honor that you're having us here with Jérôme to present about our work. Based on the description, I would assume that you think that this is something kind of a niche project working with video games, but one of the goals for us here is to convince you that this is indeed rather mainstream now, and also we want to share some of our future plans to show how we want to make it even more accessible for the research community and for the citizen science community as well. And hopefully my slides will move now. Yes, so I would assume that many of you are not gamers, or several of you are probably not gamers and may not know this term GG. This is what we put in chat when we're playing a video game and party up with other players and we want to praise their performance. It means good games. And when I talk to the game industry, I always tell them that I do believe in good games, and for the industry it means that we, you know, if you followed what happens in the game industry, it's the development, the amount of investment, the amount of innovation that is coming from the game industry is quite amazing. It's one of the most innovative places to be at the moment. And you know, with this great power, I always say that it comes, or primarily it means great responsibility. And one of the responsibilities is that we have to continuously, as game developers, we have to continuously find new and creative ways on how to contribute to the greater good and how to create experiences that on one side entertain millions or tens of millions of people, but on the other side have some relevance in real life as well. And what we are doing is just, I would say, a small piece in this epic puzzle that we're trying to solve in the game industry. So we're MMOS. We're a small Swiss company, Massively Multiplayer Online Science, and we created our company for a very specific, with a very specific core idea in mind, and that was to connect video games and video gamer communities with citizen science. This is something that I have to talk in more detail at game industry conferences, what citizen science is. Fortunately here, this is not the case. So that is something that you understand probably better than I do. What's interesting is that when I had the original idea, I had no contact to the gaming industry. I was always fascinated by the idea of or the concept of citizen science, that us outsiders can contribute to the progress of science. And when I had this idea, it was obvious that nobody has ever tried it before, because I would have heard about it. And it just felt too important to let it go. And even though I had no connection to the gaming industry, I just had to make it happen. And so I tried to make connections. And the first company that I contacted was an Icelandic company called CCP, and they're developing one of the biggest game that they're developing is EVE Online, which is a big science fiction, massively multiplayer online game, and that seemed to be a perfect fit for this concept. And luckily, CCP were super receptive to the idea, and so much so that I pitched this concept in 2015 November in Reykjavik for stakeholders at CCP, and next year at the Game Developers Conference in San Francisco, which is in March, we already launched the first collaboration together, which is really remarkable in AAA video game development. Now, AAA means that these are the highest budget video game projects that are out there. The first collaboration was together with the Human Protein Atlas. We added 250,000 of these beautiful microscopy images to the game and created a mini game where EVE players could localize or mark where they see the green staining on the images, which signify the presence of a certain type of protein on these images. And the game became an instant success. So the player community embraced it immediately. And the first 1.5 years when we were running this project, we collected over 33 million analyses of these images, which is, I would say, almost unprecedented success in citizen science, considering that this project had no roots in citizen science projects. What tells even more about this success is that game designers, of course, created rewards for this activity in game. And what you see here is an outfit, or it's called the Sisters of Eve combat suit, which was the ultimate reward in Project Discovery. And of course, game designers made some estimation of how much time it would take to unlock one of these combat suits for the most active players. And they were calculating with something like 3 to 4 weeks. Now, the first of this combat suit was unlocked 17 hours after launch, and the second on a shy 6 minutes later. That's how crazy active players were in this citizen science project. And that's when we immediately understood that we created something very powerful. This was the first major scientific publication. It was, I think, also a milestone in the sense that Nature Biotechnology considered it to be important enough to present it on the front page. Now, Nature Biotechnology, as far as I understand, are not really keen to publish fake science, so they're very picky when presenting an image which consists things which don't really exist, like a spaceship in a video game, but they simply consider this collaboration just too important for scientific research that they chose to go with this. In 2017, we switched to another research project. We, together with the University of Geneva, we introduced light curves in the game and asked players to find exoplanets, or let's say transit events, which might mark exoplanets in this data set. We're really humbled and happy that Misha Meyer accepted to be part of the project. So he got an avatar in game. He came to FanFest, which is the annual player convention of EVE Online players, and talked about his research and why players' contributions are important. Now, Misha Meyer is the researcher who discovered the first exoplanet, and he got the Nobel Prize for this achievement 2 years ago, if I remember well. So the fact that a researcher of his caliber found it important to participate in this project tells a lot about how substantial player contribution can be to the citizen science and science in general. This is a photo that I love a lot. This was taken at FanFest, this player convention. On the right, you see Michel Mayer in front of the beautiful facade of Harpa, the Reykjavik Opera House. And on the left, that is a guy who is called the Space Pope. So he always cosplays as the Ammarian, which is one of the races in the game, religious leader at this player convention. But in real life, he's actually a chief education officer at NASA's Jet Propulsion Laboratory. So this image tells a lot about the different facets of this project. Of course, one of the reasons why game developers participate in these projects, and that is something that we anticipated when we proposed this to them, is the outreach PR value that they reach. And what was really interesting is that with this project we got an overwhelmingly positive worldwide media coverage. This was one of the articles that was published around that time when we launched this collaboration. But we got into journals which is not obvious for these game companies. Also, we received a lot of prestigious awards. So one of that was the Webby Award. In the introduction, it was mentioned that we received the Innovation Award at the University of Geneva, or the Lavie Award, which before we got that award for these achievements, it was handed out to the European Space Agency and David Attenborough and these kind of personalities. So it was really a nice acknowledgement of the importance of this work. In 2020, in EVE Online, we switched to a new project. Berger Finnbogason, who is the creative director, he contacted me asking if there is anything we can help with. That was around the first wave of COVID. And because the whole pipeline was already set up, very quickly, in about 6 weeks' time, we managed to set up collaboration that was already with Jérôme, McGill University, BC Cancer Vancouver, and the University of Modena and Reggio Emilia, who were fighting on the forefront of COVID back then. And we created a mini game inside EVE Online where we analyze flow cytometry data to better understand how the immune system reacts to COVID. Now, in parallel with that, sorry, before I go on, there is this video that I want to show. This was a BBC short interview, and I think this is an important video because it tells a lot about why players are participating in these projects.
Like you look at a plot and you just draw polygons around data. You can just sit there, pull it up and start doing it. And I think that was exciting to me, just how approachable it was. And then, I mean, secondly, and probably the more important part is just how relevant it is to me. Like, I can finally relate to this.
It's really just like citizen science to a T. We had a giant group of people, and we made this fun. We gamified this quite a bit. There's incentives for people to do it that'll boost their game experience, but it's also just the heart and soul of our community as well. These are things that our people really enjoy, and this really is for the greater good. And that was the strength of this project in particular, where this came out when everybody in the world was at its height of being affected of this.
We're doing two things. Is one, we can, once we have this infrastructure in place, we can help the scientists by accelerating the ability to look at things they know are there. The other thing we can do is something they can't do, and that's look at all the possible things that are in the blood. And so what we can do is we can take even people who are not scientists and show them these data sets, and they can detect patterns with, they've done a wonderful job in the online game to explain the technology and explain the kinds of things we're looking for. And then we just let them loose on this data.
You know, you hear about the COVID research or COVID going on all around the world. A lot of people, like, you know, have had it or know someone who's had it. And just the fact that I can sit here at my desk while I'm waiting for a fleet, doing something that's going to contribute to, you know, helping find out information about COVID-19, that's just phenomenal that I have this opportunity just playing a video game. And I think that's really kind of what got me into it, is that I can sit at my desk in the comfort of my home and I can help researchers do something, you know, make a difference. And that's kind of cool.
So it's always very motivating for us to see this video. In parallel with that, back even before we launched the first collaboration with EVE Online, I started to talk to Randy Pitchford. Randy Pitchford is the founder and president of Gearbox Software, which is one of the big US game developer companies. And he immediately fell in love with the idea, and he said that he wants it in one of their games. It took roughly 5 years to make that happen. So this idea came to fruition in 2020, but it was well worth the wait, because we got into Borderlands 3. Now, Borderlands 3 was the biggest releases, if I'm not mistaken, in 2019 in the gaming industry. It's a title that is played by tens of millions, and in 2020 there was a similar minigame released inside Borderlands 3. Which became known as Borderlands Science. Again, that was a collaboration with Jérôme, McGill University, and the American God Project. And what happened in the game is that they created this beautiful arcade machine on the central spaceship of the game. And then you can go into this arcade machine, and inside the arcade machine, there is an 8-bit retro-styled Tetris / Candy Crush-like minigame, where if you move the tiles, you're trying to do DNA multiple sequence alignment. And again, let me show you a video which was a trailer that was created for this specific minigame, which explains it much better than I could do.
Hey folks, this is Mayim Bialik, actor, PhD scientist, researcher, and your favorite person. Today, I'm here to talk to you about video games and science, and how we can grab both by their necks and make them kiss, consensually. Long story short, by playing Borderlands 3, you can contribute to real-world scientific research, as in data that helps real people in meat space. Speaking of meat, did you know that more than half the cells in our bodies are alien? Only 43% of our cells are of human origin. The rest belong to foreign microbes. These microbes have a massive impact on our body's health. The more we study microbes, the more we can learn about the accumulation of meat and existential terror that is the human body. These microbes are made up of DNA, just like us. Each microbe has its own special DNA signature, and similar species of microbes have similar DNA. If we could sequence all the different species of microbes found in the human body, which, remember, make up more than half of the cells in our body, we'd learn a ton about ourselves. To that end, the Microsetta Initiative collected tens of thousands of samples of, to use the scientific term, doo-doo. Extracted the DNA of the microbes inside and sequenced it. Now we just need to organize this data. Unfortunately, though computers excel at certain tasks like crunching numbers or tracking down specific pornography, they're not so good at organizing DNA information. See, different species of microbes have similar but not quite identical DNA. That means mapping their sequences can be kind of ambiguous. The computer makes lots of small mistakes that can corrupt downstream analysis. Which brings us back to video games. So we've got several million sequences that are each 150 nucleotides long that are riddled with small errors from the computer analysis. How can we get rid of all these errors? With your help. We've taken the millions of DNA sequences and broken them down into bite-sized puzzles that you can play and solve inside Borderlands 3. And try not to think about the fact that the DNA came from human excrement when I use phrases like bite-sized. By playing Borderlands Science inside Borderlands 3, you'll be directly helping our scientists organize and compare this dung data. The game is simple. You'll be confronted with different strands of DNA, each made up of individual tiles. It's your job to place as many of these tiles as possible in their appropriate row while matching the colors. It's not always possible to line everything up perfectly, but that's okay. By playing the game and matching the sequences, you'll also be identifying the errors in our computer analysis and helping scientists across the planet build a better algorithm for the future. And since all this research is open access, the entire scientific community will benefit from it. This research could directly lead to a universal catalog of all known microbes, which could lead to new breakthroughs in food, medicine, exercise. The sky's the limit. And it all starts with you playing a video game. But if the pursuit of knowledge isn't enough of an encouragement to sort through virtual butt microbes, then fear not. Playing Borderlands Science earns you in-game currency you can spend on booster items for your characters. Oh, and this is all totally free. Just activate the Borderlands Science machine on Sanctuary 3 and sort some gut microbes.
This trailer is also interesting because it shows how much value these game developer companies can bring to a project. The kind of design that they create for such an experience, or the fact that they can create such a really cool trailer with a Hollywood star, is simply out of reach with the conventional methods of citizen science. And this is what we managed to create through these collaborations. Now, Borderlands 3, just a second.
Hey, folks.
Sorry.
Hey.
So Borderlands 3, it's a very interesting project for several reasons. Borderlands Science. One of the reasons is that this game, Borderlands 3, is a shooter game. So basically, you're running around with a shotgun. It's very quick, action-packed. You wouldn't think that science would have a place in such a game. And what happened is that game designers created something magic there, and it works perfectly. The other thing is that this minigame actually existed before. So this was one of the big successful citizen science projects, Philo, which was created by Jérôme, and which was available on the web. And what happened is that Gearbox game designers took the original game, they were playing with it, made some modifications, changed the aesthetics to fit with the game world, and then they put it into Borderlands 3. So we have a very good comparison of how this works outside of a game on the web and how it works inside of a game. Now, the day we released this minigame inside Borderlands 3, we collected 5 times more data than during the 10 years that Jérôme's team was running this project. So this tells a lot of how powerful these collaborations can be for citizen science. Just recently, this is really fresh. About 3 weeks ago, we launched our 3rd major collaboration. This time it's with Ghent University and also with NetEase, which is the 2nd biggest Chinese game developer company. And it's also a mobile game, so it's very interesting for us. Now, it's working beautifully. These projects are working beautifully, but we have some very specific challenges that we face, and I think it's only fair that we mention that. So first of all, developers are super busy. It's almost a miracle that we managed to pull off these 2 major or 3 major projects. Even the game developers are very inspired by this possibility that they can help real-life problems, but in reality, they just have too much on their plates, and they don't have the luxury to allocate a team of 2 or 3 people for a couple of months to integrate such a mini game in their games. Also, this means that we have fragmented player communities. So it's not just that we go to one game developers, create something, and that's available for all gamers, but we have to make this happen with every game developer and with each title they develop. And then on the other side of the pipeline, we see that there are a lot of niche research problems that are very important, where citizen science could contribute to a great extent. But when you look at the data, you see immediately that it will never make into a video game for several reasons. Sometimes the data set is not big enough. Sometimes the data set just doesn't look too appealing to be a good match for video games. So we identified bottlenecks everywhere, and what we came up with is as a solution is a mobile app, which doesn't sound to be too intriguing in 2022, but I think it will be actually the next big step in this story. And this graph is a bit too complicated, but what it tells is that how we work now is on the blue side is basically gamers are interacting with their favorite games. Then those games are using our citizen science API to get the data and to submit the results, and then researchers have access to the API. And what is going to be new in this process is that we are planning to create a standalone mobile app which will act as a platform which can serve as a host application for several different citizen science projects. Now, I would never think about creating a new mobile app. I think it's a very competitive landscape, and just to be noticed is next to impossible. So I would never start to think about this. But where we think that this might have a chance to succeed is that because we have already these major partners in the gaming industry. And what we plan to do is to keep this loop of engagement with in a looser manner, meaning that in this mobile app, the individual experiences would be still connected to the original game through narrative, through visuals and art style, and also through the reward cycle. And this way, we really hope that we'll be able to remove these bottlenecks, both on the gaming side and both of the research side. So please, if you're interested, and this is a big part of our job with Jérôme in the coming months, contact us, because I really believe that we'll have much more flexibility and freedom to integrate other research projects. So yeah, that is all that I wanted to share today, and I pass it over to Jérôme.
Thank you so much, Attila, for your nice presentation. And I think it's very exciting. Often we wonder, why would people contribute to these kind of initiatives? But I think it was very clear today that it's not only about the games, it's really about what people want to help and want to be involved in this kind of activities. So I would like to introduce Jérôme Waldispühl. Is an associate professor of computer science at McGill University. He holds a PhD from École Polytechnique and previously was an instructor in applied mathematics at MIT. He conducts research in RNA, structural bioinformatics, and chemoinformatics. He pioneered the use of video games to engage the public in genomic research with Philo, the game that Attila already spoke about, Colony B, and Borderline Science, and Project Discovery Phase 3. He's a recipient of Tomlinson Scientist Award and Fessenden Professorship in Science Innovation. So now I'll pass on the microphone to you, Jérôme, and afterwards we will have time for questions and discussion, but feel free to already write in the chat if you have burning questions.
Thank you for the invitation. As Attila mentioned, I'm very glad being able to have this invitation to present here. It's very a lively community I'm following myself, and even if now I'm in a European community, I'm more in North America, but it's very well renowned, and I think that's acknowledge all the work you've done to advance the field of citizen science. So Attila actually presented several of my points, but I still want to bring a bit the scientific perspective of what motivated the project. And instead of going broad, I probably focus on the landmark project that Attila and I conducted, that is Borderline Science. Because for many reasons, I think it's a turning point for the way we do citizen science, but also I think in science in general. It's a convergence of multiple movements that have been initiated before. And to some extent, I think it's a very good illustration about what this intersectoral marriage and interdisciplinarity can bring. All right, so as was said in the introduction, I'm initially working in bioinformatics. Well, I'm a computer scientist, so my what I like is to solve problems the most efficiently possible and find a good mathematical model to solve it. But over time, so during my PhD and afterward, I reapplied that specifically to the field of bioinformatics. Why? Well, because bioinformatics is full of data, very heterogeneous. The biologists are generating a very broad wealth of data, such as structures, microarrays. We saw flow cytometry here on the top right, high-C data. So it's the amount and the diversity of data generated in that field is so amazing that as very famous computer scientist, as Donald Knuth was saying, we easily have 500 years of interesting problem to work on as computer scientists, which is what motivated me at the very beginning to work there. And I was not disappointed, because as every time I was going further into this field, the diversity and how rich were the problem became just more and more interesting. So it's very encouraging, and there's a lot of things to do. But typically, it's so much data that we need to resolve on computers. But computers alone are not sufficient to solve the problem we try to address. Computers first work just on a model. This is not reality. This has nothing to do with it's just an abstraction of the word that we're making because it's easier for you to work with. But ultimately, it cannot capture all the complexity of the living object we're working with. And furthermore, even if you identify the problem you want to solve, there's no guarantee that the problem that you will solve will be actually easy and fast to solve. I mean, most of the time, they fall into a category of a problem that we call NP-hard in computer science. That means that if you want to solve the problem optimally, assuming that it's possible, which is not, you will take centuries of thousands of years just to solve it. So to solve this problem, typically what we resort on is to apply the most advanced algorithm that we can to solve the problem, but the results they return are not optimal and they are not the best. So they include a lot of many mistakes, and more importantly, these mistakes stem often the fact that they are not, the results are not contextualized, there's no background information. They don't try to find a bigger picture or find patterns that are obvious for a scientist, but not obvious for a computer because he never saw it before. So what's happening in science, like always, you have this huge amount of data, you give it to computers that generate the analysis, and after that, you have a human, that we call the scientist in that case, is looking at this data and try to fix these different mistakes, or try to correct the analysis and refine the equation, try to see what should be the next analysis that should be performed on this data to provide more robust and accurate results. And you have this cycle going on and on until it converges toward, hopefully, a valuable finding. The problem with that is that, well, the problem are huge and become more and more complex. So typically now the fundamental and big question that we have in science are no longer conducted by a single scientist or a small group of scientists. They're really consisting of teams of hundreds of scientists all around the world working together to crack specific problems. I know it's true that the public, I mean, the media likes to have this prize, like that will reward 1 or 2, 3 people at most for specific discovery, but it is not how science works, and you all know it here. This is really a movement when people are making small contribution, and sometimes a discovery arise. So the most famous project I saw in my field could be something like the ENCODE project. Why I want to show you this paper here is, like, typically the team are so big now that we have to put the name of the contributors in the supplementary material because there's no longer any room for so many people there. And the truth is, like, this movement of growing teams is not stopping, even accelerating. So at some point we're reaching a bottleneck here. That is, the more fundamental, the more deep the question becomes, the more complicated it is, the largest the team should be assembled. So we need to find new resources. And this is where citizen science and this approach of video games developed with Attila comes into play. We need more people to get engaged to solving these problems. These problems are the problem we're trying to solve, the scientific problem we're trying to address are interdisciplinary. They have multiple levels of complexity. Some tasks can be done has to be done by expert. Some other can be done by people with a less background. So you have a lot of diversity of expertise that is required to conduct this project. And there's a lot of data to analyze. And we start to think, so where can we find the workforce to work on that? We can open project to the public on a web page. We did with NASA and things like this, but this might not be sufficient. We need to find resources where with humanity spending the most of its time, and video game is one of them. So just to give you another idea, I mean, this is very old statistics now, I realize, and I need to update it, but I couldn't find numbers. But collectively, every week, we're spending something like 5,000 lifetime playing video games. If you think about it, we don't need this 5,000 lifetime, but just a fraction of it would be already a huge step forward to advance science. So following this idea, this is why in 2010, we launched the game Philo. So Philo was addressing a problem called the multiple sequence alignment that was not chosen just by randomly. It's one of the most fundamental problems in bioinformatics. Algorithms solving the problem are among the most cited in the world, and they're applicable to many areas of science, linguistics, anthropology, and of course, biology. So our idea was said, well, this problem is NP hard. Computers are doing well the job, but making a lot of different mistakes. Can I try to break it up in small pieces to help to ask humans to fix the mistake of computers? And we did it by this game. So you see that now one of the latest interface. It was not the first one that we had. Even the one that Attila showed was the second version. So it was you can imagine how awful the game was at the very beginning, but we made progresses. But we deployed that game and tried to engage the public into fixing this mistake by playing a very small puzzle like this one, like a Tetris, on this web page. And the game is very simple. So you have tiles of 4 different colors representing a DNA alphabet, ACGT. And your goal is to arrange the time by moving them horizontally, try to maximize having the homogeneity of the colors in each column. So in that case, you have the orange column in the middle, has all the same color, and you get a small bonus every time you get there. The thing is that every time that you have a mismatch of colors, or worse, that you have a gap, so like on a trading gap on the right here, you have penalties, and you basically have to find the best trade-off to solve this. So the game is fun, and but obviously it's not just about computers. The real pipeline is like, first, we ask algorithm to pre-align the genomes because we're working genomic level, and we have 3 billion characters to align. I mean, 100 times 3 billion characters to align. So the computers make the first pass. We extract the region that can be improved as video game to video gamers to improve this data and reinsert into the original alignment. I have to be fair, the step of reinsertion is probably the most trickiest one. Because there's many ways of doing it, and there's no straightforward or single approach for doing this. So it's a bit technical, but the idea is really there. So why Philo was worked so well? I mean, we had about more than 500,000 people contributing over 10 years. We collected 1 to 2 million solution to puzzles. And we showed that it was improving the alignment of some promoter genes of DNA. But it worked for 3 reasons, I think. First, because we are addressing a fundamental problem in molecular biology. If you want to engage people into solving an important problem, it has to be something that matters for not a niche of scientists, but matter for many people. So about how do you present your task to the world and convince people that it's interesting for many scientists, not just one single scientist. So that's why multiple sequence alignment was one of these tasks shared by all computer science bioinformaticians. Then we had, of course, the problem we had to address. We had first to ensure that before going further into this, that it was difficult for computers. And for that reason, we chose a problem that was NP hard, and for which one we even didn't have a good way to score the problem. Because if you can guarantee in advance that the computer works well, you cannot justify why you're using so much resources to solve it. And finally, and I think that was the real breakthrough of Philo at this point, was that our approach compared to previous science discovery game, remember we're in 2010 here, was to decide that the game has to be embedded to something that is simple. We want to create a game first. We have to create something that's enjoyable, because people play game not because it has a purpose, but because it's fun. And then after, if it has a purpose, it comes on the top of it and it creates more motivation. But we're speaking of a game, not serious game. It's the game must be fun. And what we try to build with Philo is try to get as close to a Tetris as we could. I mean, I'm not a game designer, so you can argue about my capacity of building the try game, but at least that was the intent. Our game wasn't requiring any registration, because you don't want to bother people with registration. And our game also was really about making something fun that turns out to be useful at the end. And if you like it, then you learn more about it. It was very important from a perspective to take this thing in this direction, rather than say, I want to convince people that science is interesting. I want to entertain them and then bring them to believe that science is the way to go. But the truth is that Philo was hyper successful, was working very well, but we had 500,000 people playing, but it was not enough, because the size of data we're working with is not sufficient. So we had to think about why it wasn't enough. Is because I was a scientist. I mean, I post my game on a website, and even if hundreds of thousands are visiting it, it's just a tiny fraction in the population of people playing it. We had to open to the world. And what are people really playing? Well, they're playing games like Borderlands 3. This is where millions of people and tens of millions of people are playing games. They're playing games that are fun, that are fast, and that are available on the main platform, and that benefit of the best promotion. So we need to access this market. And this is where MMOS came in with this revolutionary idea that is, well, I mean, we know where the workforce is. We know that scientists need these games. And in 2016, what Attila proposed by creating MMOS was that, well, we need, and it just explained to you before, so it breaks a bit the surprise in my talk, but it was there before, was really to say that, well, we need to bridge them together, and to bring them together because we have the resources and we have the need on both sides. And importantly, what Attila demonstrated, there is a will from both sides to work together. And that gives rise to this Borderlands science game that is basically a revamping of Philo, where instead of playing horizontally the sequence, we play now vertically. We simplify the scoring scheme to make it more accessible. We have games that you can start to play very intuitively at the beginning, a very nice progression of levels, where before it was taking like 5 minutes to solve a puzzle of Philo. Now it takes 30 seconds to generate a puzzle, and that really boosted the engagement. You see all the difference that you have between our first game here and what the game designer, and in particular Gabriel Richard at Gearbox made. And that really boosted engagement. But that was not all. There's also an art about presenting the game. And for instance, this arcade booth, that is where you can play Borderlands Science in Borderlands 3, is where you access the game. But it was very important to know where to deploy it. And we deployed it in the main spaceship of the game when everyone meets, everyone waits. And it's the base of the mission. It's the core of the game, where you start all the missions. And it was very important to think also where you present your game to the community, because it will automatically affect the visibility and the impact of the game. And I mean, we were very blessed also, I would say, with Attila, that Gearbox wanted to play this game, and they didn't want to make it a side project. They really put it at the core of their spaceship. And it means that the company was really willing to put that forward, and not just making a small project, side project to have a good press here and there, but really to engage everyone. So it comes also with a lot of powerful tools that you have in video games that brings a lot of incentive to player to play, like the skins and the bots for the different for playing the main games. So that also boosts engagement. But what was interesting for us as well is that Gearbox conducted also some survey about the different video games and asking what motivating the most the players about playing it. And the answer was science. It was probably the most important finding there, because even if we try to encapsulate into the most fancy and try to hide the game almost, at the end, what motivated the player to play this again and continue to do it is not the booster. I mean, even if it helps and everything, but it's really because they're contributing and doing science. And that opened a lot of opportunities about how to engage a broad society into together working on science. So of course, I won't have time to go into detail, but it was very important for that reason to make sure that we're also addressing a fundamental problem. And in that case, we partner with the team of Rob Knight at the University of San Diego that work on another citizen science project called the Microdata Initiatives that collects data for microbiome data analysis. So they try to understand how the microbiome in our gut influence our health. So that there are tens of thousands of people around the world that contributed to send samples, analyzing it. And the match here was perfect because it's one of the most important areas in biology today. People are already contributing, donating the data. So why not trying to engage people also in the analysis of the data? And this is why we chose to partner with it, because it was giving a purpose that is easily understandable by anyone playing the game. So that gave online science. I won't have to show this one. I'll just give you a quick idea. After 1 year, we had 2 million participants and 1,800 million solutions collected. It's 2 years now, so you can see that it improved. And so it was a huge success. And as I mentioned, it's orders of magnitude higher than what we got with Philo before. So there's multiple challenges I was mentioning here too as well. Aligning the different timeline, embrace, but very important for scientists to embrace the communication. There's fantastic tools that are put at your disposal by the video game companies, and you have to collaborate and engage every time that you can. And again, being sure that your game will be fun, because remember, we're doing citizen science games, and it has to be a game first. So there's plenty of opportunities and things like this, but perhaps you can have in discussion. I just want to have this slide with different collaborators there. I probably forgot a lot of people, but I want to, hopefully I didn't. So thanks a lot. And we'll be waiting for question now with Attila.
Thank you so much. This was super interesting. I'm gonna not entertain you any further. So please, we already have a few questions in the chat. So I'm just gonna read some of them. First, Claire was wondering about how to communicate afterwards to the gamers and the game developers what they have achieved. So I don't know if Claire wants to say something about this, or if you already have some ideas to answer this question, Jérôme and Attila.
Well, we can, but of course, if Claire wants to add something to it, we'd be happy to.
Yeah, I was just really interested because I wondered about, like, I appreciate that there's not a huge amount of opportunity to integrate this into the game, for example. But I do feel like there's a really interesting opportunity to convey back what these people have achieved and how they've supported this amazing science. And I just wondered how you handle that. And also the game developers, because they spend so long making these tools for you. And then, you know, are they looped into the process too? Do they find out what they've helped achieve?
Yeah, I think both of us will have some answers for this. First of all, when we are looking at these games and citizen science in general, I think one of the big wins for research is the data that is generated by the community. But of course, it's a really unique opportunity for science outreach and communication. I personally think that it's unique in the sense that we're involving the participants in the process and not just trying to convey a message about some scientific topic, and it's like so much more powerful than any other way to talk about science. What we've seen, and of course, we tried to use any opportunities that arose, but luckily game developers were very active partners in this, is that they were motivated to use these their communities to create opportunities for researchers to talk about their research. I mentioned, for example, that CCP invited Michel Mayor to Reykjavik so that he could talk to the player community. We oftentimes created online events like Twitch events, often viewed by thousands of players. Usually these big companies have very active player communities and also very active player community management who try to push messages about results, about why we are doing it. We were always trying to answer questions of the players, try to interact with them either in person or online or however it was possible. But generally speaking, the game developers were very good partners in this and very active partners. Also, and it's not just, you know, so one of the things about this project is that it's an amazing tool for science outreach towards the gamer communities who are participating, but also towards the broader public. So I mentioned that we had an article in the New Yorker that was primarily not targeting the gamers of EVE Online, but the general public about, you know, how games interact with science and by the way, what the Human Protein Atlas is doing. So it was also a great tool for science vulgarization. Just last year, we had 3 major documentaries about our project. Like there's a 20-minute documentary about citizen science, and it's more like 2/3 is about our projects, which is running on Amazon Prime. These are all opportunities that were created through these collaborations, often by the active help of the PR and communication departments of these companies. So that is that. And of course, we want to, we keep them in the loop. So, well, for one thing, they have more and more things to communicate to their player base, but so much so that when we are creating a scientific article, usually the couple of people from the game company are on the author list as well. So yeah, it's a very close collaboration, and there's a lot of additional values that we can create with these collaborations. Right. Jérôme, I don't know. Please let me tell me. I think you're muted.
Yeah, I'm muted.
Yeah. No, we can hear you now.
Okay.
Now,
okay,
now it's good. Yeah. Now it's good.
Yeah. Right, I pushed the right button. Or maybe I should just stop sharing here. Sorry. Yeah, I mean, I think what we have to embrace what is that communication is multidimensional in a sense that it's what it opens to me opportunity is like there is the mainstream communication, as Attila mentioned, that is the one we expect, like big papers and the scientific article eventually, but it all offers a lot of other opportunities. Like we had several Twitch channels, for instance, discussing with video game gamers, so going into their world. And it might not be sometimes a huge amount of people that can go for a couple of hundreds to thousands of people, but there's many of them and they're very interactive, taking different forms. There's a lot of opportunity that we have to embrace, and that allows every time to have a bit of a discussion going on, and it's for the benefit of the project. So this blog that we're developing, so it's good because some people want more detail. We don't have time to do it. We cannot do it because that interests in a fraction of population. But my student and myself, we can write this blog post and put them here if they want to have more detail, keep them updated what's going on. Of course, what is challenging there is like the timeline of the video game industry and the timeline of science and communication, which is perhaps the main challenge. I mean, collecting data and launching takes a lot of time, but analyzing it takes years and years and years. And often when you launch the game, you have a lot of attention on, say, weeks, months following this, perhaps a year. But the result come 2, 3, 4 years, 5 years after, sometimes decades. So that's why this continuous discussion and showing there are progresses and explaining all this progress is and will be for us the path forward to continue this. What I want to mention, maybe, I don't know if that would be exactly the question, but when I started Philo in 2010, the goal was really to try to use the power of the forces, the human resources available in video games. And I wanted to hide the scientific task as much as possible as I can within the game. But soon I realized that people were so interested by it and want to learn about it that I realized that what I found even more interesting in the end is, okay, we're producing science and it's important, but we're educating people and we're forging society. Because what you do by education is to educate people, to empower them by the science and the knowledge we have around. And in the end, Philo turned out to be more now like a teaching scientific platform through games, where we're focusing more on the massive help to scientists with online science, but both are communicating. And I don't want to break anything here, but part of the ID belong the mobile app that Attila was mentioning is to make this even more concrete and impactful for our society. So I hope that answered the question, but we can speak for hours about it.
Thank you. I'm gonna read more questions, but we are gonna have to be a bit more brief. And so Everett, that unfortunately he had to leave, but I'm sure that it's relevant for everyone here. It seems that the examples of the games for citizen science are all about pattern recognition, which is very natural activity for players of complex video games. And that one of the bottlenecks, or are there other sorts of games imaginable?
I think yes, other games are imaginable. Generally speaking, I think a large majority of online citizen science, not just what we're doing, but what, for example, is available on Zooniverse, which is by far the biggest platform, are about pattern recognition. So that's I think the most relevant form of citizen science. But definitely, and especially with this mobile app, we'll have much more freedom to create more complex like puzzles that go beyond pattern recognition.
Yeah, in general, I think it's because we have this capacity of, brain has evolved to solve visual pattern efficiently for a very long time. So we tap into what the human brain is the most efficient at, which is why we using and leveraging this possibility through games. We can imagine other things that the human brain can do well, but is the one is the most obvious. And this is one we're using in most of the game.
Right. So Rita has played Borderlands and she says she loved the fact that we both got in-game rewards, but mostly the fact that we help science IRL. Our friends group played with our personal goal of curing IBS and other gut issues. Yeah, so I think people really enjoy not only playing them, as you say, of course they have to be fun, but actually they want to know what's the scientific question behind.
Yeah, I think that if I can start here, I think because this is where you see it's important. First you have to be fun and engaging, otherwise you never play it. But after, because there's a purpose, and it's not like the main purpose of the Borderlands 3 is not to sort DNA. We have to answer why you're doing this and empower the results. The best way of teaching is not to put someone on a seat and ask him to absorb everything you're saying, is to put things in practice, like la main à la pâte, a bit what Charpak was saying in French. So in France, there was really this, the idea behind is like you're learning, but at the same time you're doing. And what you're doing is useful for advancing knowledge. And it's really the combination of all these things together that makes it efficient. And this is why it has to be fun to engage, but it has to be scientifically motivated and clear and pedagogical afterward to maintain and sustain the initiatives on the long term and make it useful.
There are a couple of questions on inclusivity and representation, because it seems, of course, the gaming community, although there are a lot of women nowadays in the gaming community, it is, of course, dominated by men. Correct me if I'm wrong.
That is not true. Sorry, that is not true. That is simply not true. That's perception of the game industry, that picture of the game industry is completely outdated. Recently, a couple of weeks ago, the European Game Developer Foundation and the ISFE, which is the European equivalent of the Entertainment Software Association in the US, which is the biggest trade association of the game industry, They published their annual report. Well, first of all, I think it's very important to see that games are not an early activity anymore. 52% of Europeans are playing games, and this number is continuously growing. It's when this question arises, I always feel like, you know, when would we ever say a sentence like whether films are inclusive? Of course, everybody watches films. It's almost impossible to find a human being on the surface of the earth who haven't seen one film. And that's the same thing that we see with games. We'll arrive there very soon. I think the global numbers are around almost 3 billion players worldwide. The gender balance is almost 50-50. Of course, there are differences in what male or female players prefer to play. So there we see other different patterns, but it's kind of a normal difference in our interests. But that's no longer true that it's primarily a male activity, or even the age groups are equaling out, and the main player, I think the biggest age group is, if I'm not mistaken, 30 to 40 or 40 to 50. So it's not like teenage boys in their parents' basement are playing games. That's not the case anymore.
Yeah, I think what I really want to emphasize what Attila said. Indeed, it's much more diverse than we think. I mean, if you look at it, there's a lot of seniors playing video games, and that's an emerging market as well. And we have to take the problem the opposite. We know that the video game community is very diverse and broad, and to make it more accessible to different communities, because science, as it is implemented today, is potentially indeed biased toward white old male, I mean, or middle-aged male, and probably not a good position like this, but I mean, this is the way it's structured we implement science in our society. There is a bias, and diversity is not a good well implemented. But this is an opportunity of using video game and a diversity of population video game to make science accessible and diverse for everyone. So I would rather present it into an optimistic view of it. And just also one comment, indeed, I was saying that, yeah, it's true. We had in the video, we have portrayed Mission Meyer, because it was him that is showing the game. But in Borderlands Science, for instance, the main hero was also a female character. It's like, I don't remember the name off the top of my head right now, Attila, but it's really portrayed by characters that are very diverse, and there's actually here again is taking advantage of what the video game industry is doing to promote diversity in the game, and taking advantage of it.
Yeah, that's really good to know that this bias and also the perception that we have of this is going on a good direction. And Everett, who is, as I said, not here anymore, he also says that for Eve specifically, they have more or less 49 or 50% ratio of male to female. So it is pretty much even.
I think Evoline actually is worse. Evoline is primary. The player base is primarily male, so it's more male dominant. But maybe that's changed a bit. But even if you go to FanFest, you see that it's mostly played by males. Maybe because of the subject, maybe because of the game mechanics. You don't know. It's more interesting for male players. But again, I want to reiterate on it that it's not that the games are moving in a good direction, but games are already there. Games are absolutely inclusive, and especially I think it's interesting to mention that there is this pattern that is also very well surveyed, that female players prefer mobiles, male players more are intrigued by PC and console games, and also puzzle games are more interesting for female players. So actually what we're planning to do is we expect it to be more interesting for female players, but that's not it's not like a direct goal. It's just you know where we'll end up based on the industry surveys that we see.
Yeah. Okay, so we also have some comments on other games and how, for example, relatives of patients with Alzheimer were particularly interested on playing these games. Kirsten has a a question. I don't know if you want to do it yourself. I think you'll probably explain it much better.
Well, I don't know if anyone knows or remembered this, but in a MMORPG, World of Warcraft, there was accidental play that predicted human behavior for a bit in the corona pandemic. And I was wondering, because the research you talked about was more on the pattern recognition and not really more the social sciences. Do you see possibilities to incorporate more behavioral or psychological citizen science research into games?
I think yes, it's absolutely doable. There was some interesting game where it's not, I wouldn't call it social sciences, but there was it was less of pattern recognition, but rather they tried to measure how players are interacting in virtual environments, which was one of the big successes in mobile games. It was the Sea Hero Quest. They were very clever approach, because they teamed up with, if I'm not mistaken, Deutsche Telekom, and they not just gave sufficient funding for the project, but they can again use their network and their reach to their end users to create substantially big enough user base, so they got something like 3 million downloads, which is quite nice for a mobile game. And I think if I remember well, they used it to research dementia, and where they were researching how players were behaving in a virtual environment, where the virtual environment were changing compared to the initial map that players were present in. But definitely, I think there, as I was saying, as we move to this next step, where we can be more independent and less rely on the resources or the in-house resources of game developers, I think we'll have more and more chance to implement different type of research, and I think we can move in the direction to implementing citizen science, which is targeting social science questions.
Yeah, I mean, I think that just to complete that, there will be also some games that have been used to try to better understand, as Zero Quest saying, but also, I think we mentioned World of Warcraft somewhere, and many different games. It's also a group in Austria very early on that's tried to work on, and completely out of my, okay, I lost the track right now, but they really use this game to understand the pattern about people always behaving in groups and creating clustering and each other. And there was this game also that tried to understand better the mechanism of pandemic using video games. It's true, it's useful. There's a lot to do there, but of course, there's always something that had to be kept in mind, is that it's a different settings. It just remains a model. I mean, people online won't behave the same that they behave in reality. And it's very well known when you see all this hate speech and things like this, like it's people feel de-inhibited because they're hiding behind a screen, or they can hide an entity, and you don't do that in real life, because you see people in front and you have a bit of empathy for the people in front of you. And fortunately, so there's many parameters like this, I want to say, that are that can vary in virtual world. So there's a lot of potential there indeed, but it has to be done really in a close collaboration with experts in the field and social biology, because I know biology is very tricky, but social science, behavioral science, and psychology is probably even more complicated. So it's just developing the collaboration and the team working there by merging all expertise. But definitely, I think it's a very good direction to look at.
So in the chat, there was another question that is not related to gender, but rather to the participants, because in the US, people that participate in citizen science initiatives are mostly white, and whether in these kind of activities that include video games, do we see more diversity in this sense?
Well, the truth is that we don't collect this data because for privacy purposes, we really isolate everything there. I don't know if you have more information than me, but me personally, on our server, I have no data. I just have numbers.
No, we don't have that data either on our side. So probably the game companies could conduct such a surveys. I think they don't have that data either as a standard part of the data set or the profile of their players, but they can conduct such surveys, and I'm sure they do it sometimes. And you know, that's true that it is a process in the sense that we cannot say that we have the same penetration with video games what we achieved with the film industry, but we will rapidly arrive to that point. And at that point, I think all these questions will become very quickly obsolete, as you know, everybody will play with the games in some sort of shape or form.
Yeah, unfortunately, we are running out of time. If there is some question from people that are right now on the room that would like to say a last question, maybe. If that is not the case, then I would like to thank you both for your amazing presentations, very interesting indeed, and thank all of the participants for their inspiring questions and discussions.